Hello there, everyone. Welcome to episode number 674 of this here electronic engineering podcast called Amelia's Weekly Fish Fry, brought to you by eejournal.com and written, produced, and hosted by yours truly, Amelia Dalton. High performance processors, especially those fueling the AI boom, are facing immense power and efficiency challenges. And folks, that's exactly what we're talking about today. My guest is Ferric CEO Dr. Noah Sturcken. Noah and I discuss how Ferric's integrated voltage regulator, or IVR technology, is directly addressing these hurdles, what makes their solutions uniquely flexible, and how power delivery is beginning to redefine processor architecture itself. So, without further ado, please welcome Noah to Fish Fry. Hi, Noah. Thank you so much for joining me.
Thank you so much for having me, Amelia.
Absolutely. Okay, so first, Noah, tell me a bit about your background and the development of the integrated voltage regulator, which is at the heart of Ferric technology.
Yeah, happy to, Amelia. So I'm an engineer by training. I got a bachelor's degree and PhD in electrical engineering. I've been fascinated by high performance computing my whole life. My father and grandfather before him both worked to develop leading computing systems in our industry. And I've spent time, actually in the trenches designing high performance processors myself. Through that experience, I came to realize that power is a serious threat to the continued improvement in processor performance. I was designing high performance logic and realized that, a noisy power supply was going to have far more impact on the timing of my circuit than any design decision I made. And so it's important to find technologies to improve power delivery for those processors. I went and got a PhD at Columbia where I worked with Professor Ken Shepard, and we developed some of the core underlying technologies to enable improved power delivery for these processors. And the way that we're doing that is by miniaturizing the power converter components to the point that they can be integrated much, much closer to those processors. So rather than having the power converters down on the motherboard, far away from the processor, these power converters can be placed immediately on top of the processor, directly under it or right next to it. And so the conclusion of my PhD, the industry was starting to pull for these types of technologies, these integrated voltage regulators. And it became apparent that I should launch Ferric, start this company to commercialize this technology and bring some of the best IVRs available to the industry. It's been kind of a long journey, but we're now delivering these IVRs into some of the highest performance AI processors in the industry and realizing the benefits from those IVRs that we anticipated something like 15 years ago now.
So, Noah, we're looking at an exponential demand for high performance computing these days. So, what do you see are the biggest challenges facing these kinds of high performance processor applications?
So, there's of course the large build out, large data centers, a large quantity or count of processors that are being implemented and used, but also on a per processor basis, the power consumption has increased dramatically over the past 10 years. In some cases, we're talking about a 10x increase in the amount of power that these processors are consuming. Meanwhile, the supply voltages, the voltage level that the processors consume that power, has been drifting to lower and lower values, going from 800 millivolts down. And as that happens, more of the power is delivered with a very high current level, and you're essentially trying to get 10x more power through the same power delivery network that you had at your disposal 10 years ago. So trying to get 10 times more current, 10 times more power through the same pipe obviously is a real serious challenge for the power engineers responsible for keeping these processors running. And so Ferric's technology alleviates this bottleneck by allowing the power to be converted on the other side of that pipe, the processor side of that pipe. So power can go in at higher voltages, lower currents, and then be down converted within the processor to alleviate this power bottleneck and enable the industry to continue improving performance and total cost of ownership for these products one generation after the next.
So, Noah, let's talk about Ferric's IVR technology. So, talk to me about the details of this technology and what sets your solutions apart from other technologies on the market today.
Yeah, so IVRs, again, are a miniaturization of what otherwise would be conventional power conversion and regulation technology. But in order to achieve the sort of miniaturization that's necessary to actually make this work, to, improve processor performance rather than impede it, we need to have something like 100x miniaturization of those power converter components. That requires innovation on all fronts. One fundamental need is in the magnetic materials that are used in these power converters. So traditional systems might use ferrite materials, big, bulky inductors. That's one of the most important components to miniaturize. To miniaturize it, we need to reduce the inductance value that the system needs, and we need to be able to operate that inductor at a higher frequency. Traditional materials that would be used in those inductors don't work well at high operating frequencies. They become very lossy and inefficient. And so I spent the better part of my PhD and then spent the past decade plus at Ferric optimizing ferromagnetic composite materials that can achieve the ideal set of properties for integrated voltage regulation. That being very high energy storage density and very low loss when operated at a high frequency. And so that's actually the origin of our company's name, Ferric, kind of relating to ferromagnetic materials, and continues to be one of our core competencies. We've licensed some of this technology to TSMC, one of the world's leading CMOS foundries, and continue to leverage our expertise in this area to drive improvements in our products and deliver industry-leading IVR solutions to our customers.
As AI systems continue to scale, do you think power delivery will shape processor architecture as much as compute itself?
I've seen this firsthand in our engagements with customers that they're in the process of designing their next processor. They have a team of architects that are, trying to optimize the operations of that processor. And then they have a team of power engineers that are trying to make sure that the power supply is going to be able to support those architectural decisions. And we've directly heard from those power engineers that the improved power regulation and power delivery that they receive from our product enables them to support architectural decisions that could not be supported with conventional power supplies. Essentially, they, might want to take a full set of AI model weights from memory, bring them into the processor. This can cause a step function increase in the power consumption for that processor. If the power supply isn't robust enough, it can droop excessively and cause a data fault. And so with a conventional power system, that sort of occurrence is likely, and the architects need to slow the processor down. They can't load all of those model weights from memory in a single cycle. They need to spread it out over 10 cycles and have an immediate compromise in the performance of that processor. So meanwhile, the IVR that we're providing to these customers enables them to demand more power from the power supply instantaneously. That allows them to implement that architectural choice and realize better performance for their product. So there's, immediate constraints that are limiting the performance of these processors, and by improving power integrity, we can alleviate those constraints and allow for better performance per watt, total cost of ownership, and peak performance.
No, what feedback are you hearing from engineers once they actually integrate IVRs into their systems?
In short, they're never going back to the old way of doing things. They realize the benefits that I've been speaking to here: improved density, improved power integrity, and ability to realize better performance and total cost of ownership out of their processor. So all of those things are realized and that creates a lot of customer enthusiasm. But then there are a lot of additional unexpected benefits, like simplification of their board design, reduction of the layer count and area that they require for their motherboards, and consequently they have cost savings and reduction in the total bill of materials for that system. And so once you kind of add up all of those benefits, you give an engineer trying to make a decision on what power supply to use, they recognize the old way of doing things is going to be not only a step back and a compromise in performance, it's also going to be more work for me, and it's going to lead to a worse result. So the IVRs are definitively the way forward. And once our customers actually get their hands on them and see them working in real time in their systems, they're convinced and never going back.
So, Noah, where is Ferric headed in the future?
We're going to continue driving performance, the kind of underlying innovation that our company has brought to the industry and these ferromagnetic composite materials. We're going to continue investing in the advancement of those material systems. We're also going to continue innovating in the way those materials are integrated with the rest of the system. So the microfabrication of the inductors that use those materials, the packaging of the system that brings all of the components together. So we're continuing to drive some really exciting advancements in those underlying capabilities that allows us to make better products, driving improvements in the key figures of merit, the density, the efficiency, the regulation performance. We see this as necessary in order to stay ahead of the requirements the industry is putting onto these power supplies. AI processor power consumption will continue to grow. And so we need to continue improving the power supplies we're creating for those AI processors. We're also working closely with some of the most sophisticated companies in the world developing these AI processors to improve the value that they're realizing by driving higher levels of integration. So a customer can take our product, they can attach it directly to their motherboard and realize the benefits that I'm speaking to here. But they can also take that same product and attach it to the package substrate of their processor, or embed it into the core of that package substrate, or attach it directly to the surface of that processor. So these are all integration schemes that get the IVR even closer to the processor, enable that processor to function even better, although it does come with the higher level of complexity that is inherent to those integration schemes. If you want to take a new technology and embed it into a state-of-the-art package substrate for a high-performance AI processor, this takes some money and some time. And so we're working closely with industry leaders in order to mature those approaches while offering sort of a buffet, a set of options for customers and how they integrate our power converters into their systems.
Excellent. Okay, Noah, it is time for your off the cuff question. So, if you could have one meal right now, it doesn't matter if it's on the other side of the world, you need a passport to get there, what would you have?
Pizza. I think that's probably the most common answer. I'm a New York native. I don't have to go across the world. I can go across the street and get some of the best pizza in the world, and I do it often. So
I love it. That is fantastic. Well, Noah, I think that's all I have time for today. Thank you so much for joining me.
thank you, Amelia. Have a great day.
If you would like even more information about this topic, I've included a couple links below the player on this week's fish frying page on eejournal.com and in the description for this week's YouTube episode as well. Well, folks, that's all I've got for this week's Fish Fry. But I've got some exciting episodes on the horizon, including my discussion with Joe Adaletta, CEO of Lexion, about the interesting intersection of battery manufacturing and advanced materials, and why some battery materials perform great in the lab but fail in real-world production. And last but certainly not least, I chat with an absolute EE rock star, Sandra Rivera from Visora. Sandra and I chat about the role of inference in AI systems and what sets this AI accelerator startup from France apart from the pack when it comes to AI inference. So you will definitely want to stick around for those episodes. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EE Journal. If LinkedIn is more your thing, I dig it. You can follow us or me on LinkedIn, and we are also on Blue Sky Social and Mastodon too. And we have a YouTube channel, youtube.com/EE Journal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series, hosted by me, and our animated series called Libby's Lab. And of course, you can subscribe to our EE Journal YouTube channel as well. Thank you, everyone, for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's Amelia, at eejournal.com, or post a comment on our forums on EE Journal. For the week of March 20th, 2026, I'm Amelia Dalton, and you've been fried.